Hello. I'll be talking about this strange concept of typical utterances, utterances that are typical for a speaker. And I'll be also talking about interaction styles. Interaction styles. So when you interact with somebody, they have a style, you have a style, and these things interact in interesting ways. What are these styles? Things like, is the person chatty or thoughtful, dominant, agreeable, calm, opinionated? And knowing the interaction style of who you're dealing with can help the conversation go smoothly. You know how to approach them, how to deal with them. So the practical motivation for this work is, before you meet somebody new, it's good to know something about them. And we always go through, we do a search on social media or Google to find out, well, what can we find out? We can find out what they look like, where they graduated from, what their job is maybe. But really what you want to know a lot of the time is, what is this person like to talk to? What is their interaction style? And existing methods tell us nothing. In many cases, this is not a real problem. In many cases, you have somebody, maybe at your workplace. If you want to talk to this little guy here, maybe you know somebody who knows him, who has interacted with him, or who has observed him in some way. And she can give you those adjectives. This guy is serious, sometimes playful, and you know how to interact with that person. But suppose you don't have that contact. So here comes the design concept. The idea is to present a single typical utterance as a distillative behavior. So if we draw that, we have the cloud of everything that this guy has said over, well, maybe the course of this working relationship, or maybe at this site, or whatever it is, not clear, that goes into the still, and out pops a typical utterance. You, the user, can listen to that typical utterance and say, okay, now I know something about this guy. So there's the idea. We're interested in perceptions of interaction styles, and we're exploring them through this concept of speaker typical utterances, maybe with an applications at the end. All right, research questions. Does this work? Can observers perceive interaction style information from just a single typical utterance? And what interaction styles exist anyway? All right, so we're exploring these things through building a model. So there's a computational model behind this, and I'll describe how that works and how it succeeded. Describe the experiments. Experiments with human subjects show that they do like this in general. It does work. And a more general discussion at the end. The most interesting related research is that on thin slicing. So in social psychology, there's this observation that people tend to make social judgments based on very short behavior samples. And this can be done experimentally. So you can show somebody a 30-second clip of a hiring interview, or the first 10 seconds of a speed dating interaction, or the first few seconds of a professor walking into a class at the beginning of the semester. You can have people judge. Will this person get hired? Will this date lead to success? What rating will the teacher get at the end of the semester? And based on these short samples, 5 minutes, 1 minute, 30 seconds, maybe less, people can actually pretty well predict the ultimate outcome. So this is maybe a little bit scary. Do we really rush to judgment? Is that a fair thing to do to people? But from the other perspective, it's good, right? So if you can very quickly, if humans have evolved to the point where we can very quickly understand enough about another person to know what we'll think about them, to know how to interact with them, that's a good thing. It makes life go smoothly. How do people do this? Well, presumably it's the subconscious prosodic and acoustic features of how other people speak. Of course, clothing, appearance, facial gesture, all that too, but the talk today is focusing on the audio side. AI systems can do the same. So they don't really explain how they work. It's machine learning black boxes, just like humans can't explain how they reach these judgments. But ablation studies show that really many of these judgments are based on acoustic and prosodic features, the way people talk, not so much the words that they say. All right, so if we're going to build this out into the direction of applications, there's a few challenges. Rather than just supporting coming up with a single rating, likely to hire, unlikely to hire, we're interested in supporting general judgments about people. Rather than working with video, we're interested in audio only. That's to keep the experiment simple. More interestingly, rather than presenting subjects with the speaker information, the interlocutor information, and the context, we just give the speaker information only and a single utterance. Kind of aggressive. You might wonder, is that going to work? Let me give you an example to maybe convince you that it does. So here's a 5-second clip from somebody in conversation.
Well, no, it's probably going to be a very old use when my husband had an accident.
Okay, so from that you can probably infer that they're talking about buying a car, and maybe this has been a topic for a little bit. What can you tell about the interaction style, the likely interaction style of the speaker?
Well, no, it's probably going to be a very old use when my husband had an accident.
Yeah, you may be starting to form some impressions. Maybe she's serious, maybe she's thoughtful, maybe she's mature. Okay, so there is a lot of information in a single utterance, at least when the utterance is taken from a dialogue and you have the clear audio. All right, now given this context, we're interested in not just the first moments, which is what thin slicing research usually focuses on, but since we have the recordings, we can pick the most informative slice anywhere in the context. So how do we do that? Well, the basic modeling concept is we'll just take an average utterance. If it's truly average, it should be typical and informative. This is a visualization of a vector space with 2 dimensions. For now, you can imagine that the x-axis is how fast the person speaks, and the y-axis is how much they pause, or what their pitch range is, some features that capture something about their style. Little squares represent all the utterances by that person. The little red square represents the speaker centroid. So if we pick that utterance, maybe that'll be informative. Generally it is, but we can do a little bit better. The problem is that the global centroid, that's the little red circle here, for all speakers is usually not too far from the speaker centroid. People are pretty similar. So we want to sort of exaggerate. We're going to go in the other direction and pick what we call a caricature point, something that's in the other direction. And it turns out that a distance of 1.5 seems to work very well. I'll try and convince you that this is a good thing. I'll give you 2 clips to listen to. One is the centroid, one is the caricature. And I want you to ask you, which one is more distinctive?
The high scoring, there's no defense, it seems like, and I just kind of score.
All right, that's the centroid for the speaker. Caricature.
What I was doing at home, in fact, I work nights here, so that's another long story we'll talk about.
All right, maybe the second one is more distinctive. Maybe it aligns better with the adjectives that you would come up with if you had the opportunity to listen to a longer sample of speech from the speaker to meet them. So that's the claim. So the caricature utterance is going to help you figure out what this person is really like. All the adjectives I have here are 10 speakers, 10 participants in our experiment who listened to 3 minutes by this speaker and came up with descriptions of his interaction style. Okay, so a little bit of detail on the vector space. So we have an underlying assumption is that interaction styles are just the use patterns of pragmatic functions. So pragmatic functions, things like questioning, informing, confirming, disagreeing, agreeing, teasing, empathizing, comparing, making implications. So those are the things you do with sentences or utterances. And the interaction style is just sort of the aggregate of everything that you do with your utterances. Simplification, of course, but a useful one. So if that's our model, then we need an embedding, a vector space, that represents the pragmatic functions. There are embeddings that represent speaker identity and semantic content and all these things, but we need something that represents pragmatic functions, and we found one. This is another paper, but the vector space represents pragmatic functions. It's a subset of the Hubert embedding. If you think of large language models and pre-training, this is the same thing for speech. The Hubert embedding is a well-known embedding. We're interested in adjusting that to represent specifically pragmatic similarity, modeling by Euclidean distance, and we chose a subset of 103 features out of the Hubert embedding that gives good performance for modeling human judgments of pragmatic similarity. So long story short, we have a set of features that allows us to compute the average in terms of the average pragmatic function. Okay, getting into the experiment. 2 hypotheses. Caricature utterances will be considered more typical, and typical utterances will be considered useful. So to test these little experiments hypotheses, it took us a 4-hour session, and this session involved 11 speakers, and for each of those we had the participants listen to 5 clips and rate each for typicality. We hoped that the caricature clip would be rated more typical.
Well, no, it's probably going to be a very old use when my husband had an accident.
Okay, these are 5-second clips. Now, in order to judge whether that's typical for the speaker, you need something to go by. And so we had them listen to 3 minutes of data from the speaker. And to keep them alert, we had them choose descriptors like dominant or aggressive or cheerful or whatever it is. Okay, I won't give you 3 minutes of data, but I'll give you a slightly longer sample from this speaker.
Wall Street Journal.
Do you get a chance to do it at home, or do you mostly like catch up while you're at work? Do you have a chance to look through the Wall Street Journal? I'm not sure what you do.
Yeah, well, at the office, I generally catch the Wall Street Journal at lunchtime. Use part of my.
Okay, that's enough of that. Okay, so the overall perspective is we listen to the five clips first. We write down some descriptors just to get them familiar with them, get them familiar with the speaker's voice. Then 3 minutes of data from the same speaker, write down some more descriptors. And then, this is the payoff, they listen to the 5 clips and rate each for typicality. And then, as a bonus, we also have them make utility judgments. How useful would it actually be to hear a single typical clip if you're making judgments about the speaker? All right, results. Typicality. So the caricature was the most typical. By a linear mixed model, it did better than the random control and a few other cases. It didn't do quite as well as the human chosen most typical utterances, but it's in the same ballpark, 3.58 versus 3.51 on a scale from 1 to 5. No significant difference by a t-test. So our little algorithm for picking the caricature is doing pretty good. The utility ratings, we had the subjects say, how useful would it be to have a most typical utterance for selecting a counselor, someone to be your counselor, or someone to be your teammate, and so on and so forth. Overall, only 4 of the ratings were no value. So people perceived value in this. And for some of them, like choosing a counselor, it was felt to be like 4 on a scale from 4 to 5. So not exceedingly useful, but useful. We also found that there's a lot of variety in what people perceive. Things that you would expect: friendly, confident, agreeable, mature, extroverted, thoughtful. These were among the most common descriptors that we had. But we also had some one-offs, so things like abstract, blustery, cursory, lightweight, modern, puerile, resolute, transparent. I'm not sure exactly what the subjects meant by those things when they wrote those down, but it clearly meant something to them. So perceptions of interaction styles are pretty rich. There is some work that claims that you can represent most of what you need to know about a person with 5, big 5 dimensions or the big 2 dimensions. I'm skeptical. Rather than just giving the users 1 or 2 or 3 or 4 dimensional descriptors, actually giving the samples can be much richer, can be a lot more information. And the 4th result was kind of interesting. So the single utterance judgments, they represent the overall judgments. They're rich, but they do have biases. So this is kind of hard to see, but we found that for some descriptors, like engaged and supportive, the number of times those were chosen after listening to a single utterance was very small compared to the number of times they were chosen after listening to 3 minutes of data. And that makes sense. You can't really judge if somebody's engaged just from a single utterance. You need more. So that's a limitation of this approach. Another limitation is that things like irritating and monotone were much more chosen in the monotone condition, in the single utterance condition, than in the overall condition. That is to say, if you listen to a single utterance of somebody in isolation, you may misperceive them to be irritating or monotone or somebody you wouldn't want to interact with. So that's a limitation. We did find, however, that this bias decreased over the course of the 4-hour experiment. So with more exposure, the bias is less prevalent. All right, let's go back to the practical motivation. So I talked about the use case of meeting someone new. Right, you're going to meet somebody, you get an utterance, you say, okay, now I can deal with this person a little bit better. I know what to expect going into the conversation. Or you could also use it for filtering who to meet, right? Listen to a bunch of clips from potential counselors or consultants and say, yeah, this guy, yeah, I'll give him a call. Just based on a typical utterance, not going to be highly reliable, but maybe a useful complement to the information we use today. And a third use case, before that, practical considerations. Will people actually make their speech available? Is this going to work? Not sure. It may in certain contexts. In a workplace, you might imagine a call center where calls are being recorded all the time. Or maybe a dating app where you, instead of just uploading your picture, you can upload some audio. That's a problem to work out. our last case is helping track clinical conditions. So this relates to the interests of our sponsors, which is primarily the AI Institute for Exceptional Education, which is concerned with helping speech-language pathologists go into the schools and help diagnose children and treat children with various autism or developmental language disorder or whatever speech condition they have. Speech-language pathologists are overworked. There's not enough of them to go around. Can we make their jobs easier? So our concept was that the ability to quickly find and hear a typical utterance by a speaker could be useful to them. And in a little survey, 6 of 18 respondents agreed, and they thought it would be very useful to provide examples in assessment reports. So if you're interested in a child's behavior as it changes over time, you want to document that so that you, a year later, or maybe the next person, can actually listen to that and see what's going on. So they thought that would be useful, and also to help parents and children understand the diagnosis and recommendations. So rather than just talking abstractly about communication properties, if you say, this is a typical utterance from your child, now here's a typical utterance from a larger population of children at the same age, we can notice. So that was what they thought. We also did a 12-minute experiment, kind of like the 25-minute experiment, sort of like the one that I described with the subjects. And after this experiment, 6 of the 9 participants agreed that this could be useful for speech pathologists. Next steps, we'd like to explore group typical utterances, right? So group typical utterances, what's really typical for female speakers or Texas speakers or males of a certain age. That could be really fun for social linguistics. To summarize, we have shown that we have found a way to find typical utterances. It's caricatures in a pragmatics-related vector space. We have shown that people can perceive useful things about interaction styles from single utterances, and typical utterances are considered useful for this purpose.